Welcome to the fourth section of this course. In this section, we will study design patterns and principles of clean code. In this section, we will study the solid principles and how we can apply them to our JavaScript applications. We will then examine 3 design patterns that can really take your JavaScript apps to the next level. Those patterns are the singleton pattern, the observer pattern, and finally, the strategy pattern. In this video, we will study one of the solid principles, specifically that of single responsibility. This video will serve 2 purposes. First, it will introduce you to the solid principles. Then, we will study the single responsibility principle, which is part of solid, and we will apply it to an example with JavaScript classes in order to produce better, cleaner code. So far, you may be wondering, what does solid mean? Well, solid is clearly a mnemonic acronym. It's actually a group of 5 object-oriented principles. S stands for the single responsibility principle. O stands for the open-closed principle. L stands for the Liskov substitution principle. I for interface segregation, and D for dependency inversion. Too many buzzwords, I know, but don't stress out. The principles are really simple in nature, even if their names sound scary. Plus, once you learn them, you can throw these words around impressing managers and recruiters at job interviews. Solid principles are applied mainly to object-oriented concepts. They are pretty common with Java or C#, but are less known in the JavaScript world. Knowing them and how to apply them to JavaScript, however, will give you a distinct advantage. We studied the single responsibility principle during a previous section, but back then, we concentrated to functions. In this video, we will talk about single responsibility in the concept of classes. Classes should generally do one thing. That does not mean that you shouldn't have multiple methods. It just means that a class should be responsible about a very specific area of an application. The best way to understand how the single responsibility principle works when it comes to classes is to see an example of a violation of the single responsibility principle. So in this example, our code will violate the principle, and then we will take the necessary steps to fix the issue. So we will begin writing the code the wrong way so that you can understand when you need to change the way you code. That way, if you find yourself in a situation where you might be violating the single responsibility principle, you will instantly realize it and take the steps that you need to take in order to fix it. So, in this example, we will create an HTTP client responsible for fetching some data from an API and also handling the errors that the API might throw. For example, you might be unauthorized or there might be something wrong with the server, stuff like that. I'm creating a new class, the HTTP client class. Inside it, I will implement a simple get method. We will just use get for now. We're not going to go with delete or post. I'm going to use the fetch API, the new browser API for performing HTTP requests. Within it, I am going to specify a header because most APIs return the data in JSON format. And then I will decode the JSON data. But first, I will have to check whether the response was okay or not. This is a way that fetch uses to notify us when the response has gone wrong. It doesn't throw an exception, it just sets the OK field of the response object to false. So if response.ok equals true, we return the data. If it doesn't, we will log an error, a generic error message for now, just to see that our HTTP client is working, and later we will provide specific error messages for specific types of errors, like a 404 or a 401, and an authorized error. So for now, let's print the status code. So I'm going to use the response.status field, and we're okay. And of course, I need to return that in order for the promise to work and return the data in case of a success. Back to the app.js file where we will make use of the HTTP client. I'm going to import it. I'm going to use ES6 modules since they are faster. I've also configured a Webpack installation for this project. I'm instantiating the HTTP client. I use the get method, I pass in the posts URL from JSON placeholder, and when the data arrives, I'm going to print it to the console window. So if we run this application, you can see that we do get back the posts because everything is working correctly. But what if something went wrong? To do that, to simulate an error code returned by the API, we're going to use the http://stat.us API. This is an API specifically designed in a way that will return errors. So if I go back to our code and use the http state.us / the error code that I want to simulate, if I run the application, I will get that error code. In this case, it's the HTTP error 500, the internal server error. But this isn't the most elegant way of handling errors. So if I go back to the project and visit the HTTP client, I can go inside the else block where we manage our errors and handle each error differently. Some common errors that may be returned by an API are the 401, the unauthorized error, where we will print something in the form of "you are not authorized to view this content." Then we have the 404, which is the not found error. So we can print something like content not found. Of course, you can customize that. Next, we have the internal server error, the one that we threw in this example. So we're going to go with response.status equals 500. In this case, let's just print the internal server error. And let's also provide a generic handler for all errors. So we're going to say unknown error. You don't have to handle every error code, every HTTP error code out there. If I refresh, you see that we get an internal server error, which is a better error code. It's more user-friendly, but nowhere near where we want it to be. If we change it to unauthorized, we get the message that we are not authorized to view this content too. So it works with different error codes, that's for sure. But printing error messages to the console is not the best and most user-friendly way of handling errors. Remember, the user almost never looks at the console. So we're going to use the toaster, an awesome library for notifications. You can see they have a demo here. You can have success messages, you can have warnings, you can have errors. So we're going to use this library. I am going to pull it from npm in our project, install it, and use it. So in order to do that, let's go from step 1. We are going to npm install the toaster library. We're going to wait for it to install, and later we will import it to our project. So toaster was successfully installed. We are ready to go to the http client.js file and import it. We're going to use a syntax that's slightly different. We're going to use the import star, which means import everything as toaster from the toaster library. This will import the default object that's exported from the toaster library. And then we are able to use toaster as an object. Toaster has methods for error, warning, info, and messages like that. So we're going to go with an error for the 401, a warning for the 404, another error for the 500, and of course an info for the unknown error. That's to demonstrate different ways in which you can handle several messages, not just errors. Let's head back to the browser, and it's not updated, which means that we forgot to compile it. So I'm going to go with webpack --watch that will watch the files for changes and automatically recompile. And you can see that we get the message in the browser, but not like we saw in the toaster demo. That's because we have some CSS missing. We need to go to the index.html file and include the CSS that toaster exports and makes use of. There are various ways in which you can do that. You can also use Webpack if you like, but the fastest way in which I can do that now is to just include a link, tag, and use the path to toaster, which is node modules /toaster/build/toaster min.css, which is the minified version of toaster's CSS. Now, if I save this and get back to the browser, you're gonna see that we will indeed have the correct format for our error messages. So you can see this red message, you are not authorized to view this content. It was successfully displayed on the top right of the screen. You can move that if you like. Toaster is really great in producing messages like this. But so far, what did we do wrong that violates the single responsibility principle? Well, obviously, this block of code, the else where we handle the error, is a clear violation of the single responsibility principle. We use the HTTP client to handle errors. The HTTP client doesn't need to know that we use toaster to handle errors. What if you take this library and use it in another project, where instead of using toaster, you use some other library, or you swallow errors and just print them in the console? You will have to modify your HTTP client class without actually modifying the behavior of the class, because HTTP client is meant to fetch data from the server and later post data to the server or delete data from the server. It's not the responsibility of the HTTP client to handle errors, and we will delegate the responsibility to a separate class. Let's name that class error handler, and let's go ahead and create a separate file for that class. Then we can go ahead and copy the toaster import first from the HTTP client. Actually, I'm going to cut it. We don't need that in the HTTP client. It's not a dependency of the HTTP client. Then we are going to create a new class called error handler that will expose a single method called, let's say, handle. You can make this a static method so that you do not have to instantiate the error handler. And in here, I'm going to paste the contents of the else block. They are going to be pasted right here. We don't need to change anything. We can just go ahead in the HTTP client.js file and import the error handler from the local file and use the handle static method to handle the error. Just like this. So if we go back to the browser, you see that it works the same way. Let's change this back to 404, refresh, and indeed it works with a separate error handler. Now both of our classes are clean. If we need to stop using toaster, we can just go in the error handler and change it. We will be changing the error handler's basic functionality that way. But if we handle errors in the HTTP client, changing the library from toaster to something else would mean to change something in the HTTP client that doesn't have to do with the client itself. But the single responsibility principle provides us with this convenience.